Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we talked about analysis of time series, various components of time series, various types of index numbers, and cost of living index number, and index number for industrial production. In continuance with the talk about the index numbers and time series, the next in line is the discussion about statistical quality control, which is very important technique applied for industries. The objective of this session is to discuss about statistical quality control in detail. Basically, what is meant by SQC? Statistical quality control, abbreviated as SQC, is one of the most important applications of the statistical techniques in industry. We have studied various statistical techniques. All those statistical techniques has to be applied somewhere. These important application of statistical technique is done in industry for the concept of quality control. And these techniques are based on the theory of probability and sampling, and being extensively used in almost all industries such as armament, aircraft, automobile, textile, electrical equipments, plastic, rubber, electronics, chemicals, petroleum, transportation, medicine. Everywhere the statistical techniques are applied. By quality, we mean an attribute of the product that determines its fitness for use. The range of these attributes is pretty wide: physical, chemical, aesthetic, etc. The important concept is a synergy. What is meant by synergy? A product may have several aspects of quality as well as an overall quality, a particular quality in respect of a particular product, but when you talk about the overall quantity when compared to the other products, which is something more than the sum of its individual quality aspects. So, a property technically known as synergy. So, quality here means a level or standard of the product, which in turn depends on 4 M's. What is that 4 M's? That is materials, manpower is the second M, machine is the third M, and management is the fourth M. So, actually quality control is a powerful productivity technique for effective diagnosis of a lack of quality or a conformity to settled standards in any of the materials, process, machines or end products. In all aspects we have to talk about quality. That is, when you take the material for production, there also we should maintain the quality, that is it should satisfy some kind of specifications mentioned for the material. And after the material is applied for production, during the process also we have to talk about quality. Again, it should conform to settled standards. And when the process is going on, quality of machine, because the process should go on smoothly, so quality of machine also should be talked about. So, machine should function smoothly without any kind of problem. So, quality of machine also is to be taken into account. And after the material is processed through quality machines, then we obtain an end product. That end product quality also has to be checked before it goes to the market. So, quality everywhere has to be checked, whether it is for the basic raw material or during the process or the machine or the end products. It is essential the end products possess the quality that the consumer expects of them. For the progress of industry depends on the successful marketing of products. When the end product is of quality, then product will be successfully marketed and the industry gets its own benefit and own profit. So, quality control ensures this by insisting on quality specifications all along the line from the arrival of materials through each of their processing till the final delivering of goods. As we talked about, there are 4 M's that has to be taken into account when we talk about quality control. The 4 M's are materials, manpower, machine and then management. So, quality control therefore covers all the factors and process of production which may be broadly classified as follows. First of all, quality of materials. Material of good quality will result in smooth processing, thereby reducing the waste and increasing the output. So, the waste will be reduced and increased output will be got when we process very good raw materials. So, it will give better finish to the end product. Then next, quality of manpower. Who has to process the material? Somebody else has to process. So, the manpower is very important when you talk about the quality. That is, trained and qualified personnel will give increased efficiency due to the better quality production through the application of their excellent technical skills and also reduce production cost and waste. If the personnel is not trained or it is not qualified, then we may process the material so many times by trial and error method, and this will increase the waste products. So, trained and qualified personnel is very important because their application of skills will give better quality production and it will ultimately reduce the production cost as well as the waste. Next, third M is machine, quality of machines. So, better quality equipment will result in efficient work, because once a machine breaks down, there is always a wastage of time, wastage of manpower and wastage of materials. So, a smooth functioning of the machine will result in efficient work. Therefore, maintenance of machines with good quality is very important. So, thus it reduces the cost of defectives when quality machines are used. The fourth M is management, quality of management. A good management is imperative for increase in efficiency, harmony in relations and growth of business and markets. What is the purpose of statistical quality control? That is, what is the basis of statistical quality control? Why the word SQC has come up, that has to be studied. That is, the basis of statistical quality control is the degree of variability in the size or the magnitude of a given characteristic of the product. Next very important thing is what are the variable causes of variations in quality. Why the particular product is not up to the standard for specified by the quality, means we have to check about what are the causes of variations in quality. So, variations in the quality of a manufactured product in the repetitive process in industry is inherent and inevitable. So, the variations are broadly classified into two causes, that is chance causes and assignable causes. First of all, chance causes. Some stable pattern of variation or a constant cause system, that is which is very standard, we say it is called a chance causes, is inherent in any particular scheme of production and inspection. This pattern always results from many minor causes that behave in a completely randomized manner. The variation due to these causes is beyond the control of human hand and it cannot be prevented or eliminated under any circumstances. So, we have to go along with the quality, keeping in mind the chance causes. So, we have to keep the chance causes in control so that it does not affect the quality of the end product. One has got to allow for variation within this stable pattern, usually termed as allowable variation. So, the range of such variation is always called as natural tolerance of the process. That is, we have to tolerate these causes because it cannot be eliminated. So, we have to tolerate these causes of variation, and we have to go along with the quality so that the end product is not much affected. The next causes of variation is assignable causes of variation. The second type of variation attributed to any production process is due to non-random or the so called assignable causes and is termed as preventable variation. When these causes of variation is present, then it must be eliminated. So, the assignable causes may creep at any stage of a process right from the arrival of the raw materials to the final delivery of goods. This has to be eliminated, and it can be eliminated. Okay. Some of the important factors of assignable causes of variation are substandard or defective raw materials, new techniques which is introduced for better production and which is tested by trial and error method. So, this kind of variations are called assignable causes of variations. And also another cause, assignable cause of variation is operations and negligence of the operators, wrong or improper handling of machines, faulty equipment, unskilled or inexperienced technical staff, and these are assignable causes of variations, and it can be prevented. For example, when you check the quality of raw materials, the first assignable cause called defective raw materials can be eliminated. And when you apply the new technique, if it seems that the quality is not maintained, just avoid using the new technique. And if the operator is negligent, then you have to completely terminate the operator. If the wrong and improper handling of machines is one of the cause of variation, then you have to be careful in handling the machines very carefully. And then if there is a faulty equipment, that equipment has to be avoided for the production. And if the unskilled and inexperienced technical staff is present, then those staff has to be changed with skilled or experienced technical staff. They have to be replaced with skilled or experienced technical staff for better production and quality production. So, these causes can be identified and eliminated, and very important thing is they are to be discovered in a production process, that is before the end product comes out. So, before it goes wrong, that is before the production becomes defective. Now, when you compare the chance causes of variation and assignable causes of variations, the following factors are compared. Chance causes of variation consist of many individual causes, whereas assignable cause of variation consists of just a few individual causes. Any one chance cause result in a small amount of variation, whereas any one assignable cause can result in a large amount of variation. Chance variation cannot economically be deleted from a process, whereas the presence of assignable variation can be detected, and any action to eliminate the cause is usually economically justified. Also, some typical chance causes of variations are slight vibration of a machine, lack of human perfection in reading instruments or settling controls, and voltage fluctuations or variation in temperatures. Whereas assignable causes of variations, typical assignable causes of variation are negligence of operator, defective raw material, faulty equipment, and a malhandling of machines. Now, after studying about the causes of variation, when should we call the production process is in quality control? quality control in the sense statistical quality control. So, a production process is said to be in a state of statistical quality control if it is governed by chance causes alone in the absence of assignable causes of variations. That is, if the assignable causes of variations are present, if it is eliminated and only chance causes of variations are allowed, then we call the production process is in the state of statistical quality control. So, the basic definition given by Duncan is SQC, statistical quality control, may be broadly defined as that industrial management technique by means of which product of uniform acceptable quality are manufactured. Okay. So, uniformity is very important and quality is important. It is mainly concerned with setting things right rather than discovering and rejecting those made wrong. So, instead of after discovering and rejecting, before itself we have to settle it correctly. That is what Duncan says according to statistical quality control. Another author has given the definition for statistical quality control. Statistical quality control refers to the systematic control of those variables encountered in a manufacturing process which affect the excellence of the end product. Such variables are from the applications of materials, men, machines and manufacturing conditions. Another author called Grant has given the definition as simply a statistical method for determining the extent to which quality goals are being met without necessarily checking every item produced and for indicating whether or not the variations which occur are exceeding the normal expectations. So, SQC also enables us to decide whether to reject or accept a particular product. Quality control, how to approach the quality control and what are the benefits of quality control? A planned collection of data, analysis and interpretation, improvement in product quality and design, reduction in operating costs and losses, a reduction in scrap, saving in excess uses of materials, removing production bottlenecks and reduction in inspection. Often stopping the procedure and inspecting also causes quality defect. Therefore, reduction in inspection, evaluation of scientific tolerances, improvement of employee morals, that is by giving them lots of allowance, the employee will be happy enough to operate the machine. So, improvement of employee morals, maintenance of operating efficiency, quality, consciousness, greater customer satisfaction, all these leads to enhanced productivity. Now, there are two types of statistical quality control. One is process control, another one is product control. Okay. In other words, we want to ensure that proportion of defective items in the manufactured product is not too large. That is, this is termed as process control and is achieved through the technique of control charts. The next one is product control. On the other hand, by product control we mean controlling the quality of the product by critical examination at strategic points, and this is achieved through sampling inspection plans. So, the first few episodes will be covered with process control, that is drawing various control charts, and the next episodes will be covered with various kinds of sampling inspection plans. So, hereafterwards we will be studying in detail about process control and product control. First of all, we talk about process control. Basic techniques of SQC is broadly classified into two parts. One is process control and another one is product control. And when we talk about process control, this is done with the control charts, and product control is done with the sampling inspection plan. Control charts are divided into two parts, that is control charts for variables and control chart for attributes. The term attributes we have seen in one of the course called statistical methods 2. For variables, what are the variables taken into account for control chart are X bar chart and R chart. X bar means mean chart, R is range chart, and then sigma chart. Sigma is standard deviation chart, and attributes is C chart for quality and NP chart for number of defectives and P chart for the proportion of defectives. Okay. So, all these we are going to discuss, that is we are going to discuss about X bar chart, R chart, sigma charts with respect to control charts for variables, and in attributes, control chart for attributes we are going to talk about C chart, NP chart and P chart. In product control, we are going to talk about sampling inspection plans for attributes and sampling inspection plans for variables. Control limits or specification limits and tolerance limits. Process control, that is we will talk about control charts. So, for control charts, these three types of limits are very important, that is control limits, specification limits and tolerance limits. We will see one by one what are these limits called as. Control limits, these are limits of sampling variation of a statistical measures. Example, mean, range and fraction defective, such that suppose if production process is under control, the values of the measures calculated from different rational subgroups will lie within these limits. Then we say the whole process is under statistical quality control. Points falling outside control limits indicate the process is not operating under a system of chance causes, that is assignable causes of variations are present and it must be eliminated. So, control limits are used in control charts. The next one is specification limits. We have to specify what are the limits allowed. So, when an article is proposed to be manufactured, the manufacturer first of all have to decide upon the maximum and minimum allowable dimensions of some quality characteristics, so that the product can be gainfully utilized for which it is intended. If the dimensions are beyond these limits, the product is defected, is treated as defective and it cannot be used. So, the maximum minimum limits of variations of individual items as mentioned in the product design are called specification limits. Control limits specify whether the product is in control or not, and specification limits are actually maximum and minimum limits. Specification limits mentions whatever the dimensions which should not go beyond the maximum and it should not go beyond the minimum limits. Next is tolerance limits. These are limits of variations of a quality measure of the product between which at least a specified proportion of the product is expected to lie. That is so much of tolerance is allowed, that kind of statement is given by the tolerance limits with a given probability, provided the process is in a state of statistical quality control. For example, we may claim that a probability of 0.99 that at least 90% of the products will have dimensions between some stated limits. So, these limits are also known as statistical tolerance limits. After studying about the limits, we next step in to study about the control charts. General theory of control charts is actually in industry, one is faced with two kinds of problems. What are the two kinds of problems? To check whether the process is conforming to standards laid down, that is the standards already pre-written, whether the process is conforming to that, and to improve the level of standards and reduce the variability consistent with cost consideration. And Schwartz control chart provides answers to both the problems. First of all, control chart is a simple pictorial device for detecting unnatural patterns of variations in data resulting from repetitive process. Control charts also tells us at a glance whether the sample point lies within a 3 sigma control limits. 3 sigma is the control limit specified limits. So, the chart actually tells us whether the points, the sample points are lying within 3 sigma control limits or not. Any sample point going outside 3 sigma control limits is an indication of the lack of statistical control, and we would say the process is not under quality control. So, in that case it may be the assignable causes of variations are traced and it is identified, and at that case and at that particular point it will be eliminated. And when you draw the quality control charts, 4 points has to be taken into account. That is, first of all, quality scale, then plotted samples, sample points are plotted in the chart, then sample numbers and horizontal lines. That is, horizontal lines are upper control line and lower control line and actual control line. These are 3 horizontal lines. In this session, we talked about the statistical quality control in various aspects. That is, statistical quality control definition given by various authors was discussed, benefits of statistical quality control, techniques of statistical quality control, and major division of SQC, that is product control and process control. Also, we were discussing about control charts. Control charts basics were discussed, and we also discussed about the major parts of control charts. Based on the discussion in this session, the following questions may be posed. Define statistical quality control. What are the various causes of variations in statistical quality control? Compare chance causes of variations with assignable causes of variation. What are the control charts and what are the major parts of control charts? What are the various limits in statistical quality control? Thank you.